Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner Training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you. Welcome back team, and let's get started. I think once the recording is started, the actual flow will happen. Right, so we have got to know a lot of basics, right, so far, right, and by this time you all understood that there are a number of different ways are available in order to bring up the application and run the application and access the application from the end user side, correct? There is no standard a process here, like everyone has to follow the same process everywhere in across all the companies, all the projects, no, right? There are different ways how you are going to deploy and run the application. It could be a standalone EC2 servers, it could be a on-premises, could be a Docker, could be a Kubernetes, right? The routing can be through a load balancer, or you can use any other approach. You got me, guys? What I'm trying to, right? So as much as possible, I'm trying to cover up all the different ways of how we are going to run the application. So at least the primary things, but understand that there are n number of different ways are available how you are able to run the application and access the application, right? Being said that, once you have got this much of knowledge, by looking into the architecture itself, we should be able to visualize how it gonna be working in the actual environment, right? Because if you have 10 different possibilities to implement a one single uh, to solve a one single problem, so definitely it's not possible to go and implement all the 10 different ways how we can achieve this. Getting me? So in the architecture itself, right, we should able to understand that okay, these are the different 10 possibilities that how we can achieve this. If you are able to understand that process, this is good enough, right? Which one you wanted to pick up, you just pick up that and try to do the implementation, right, in the real time too, right? We are not going to do all of this, right, and implemented it. Hope you got me what I'm trying to. Anyway, so now come back to our story, right? You can talk to me, guys, on the chat window. So come back to this slide, right? So our goal is now to build and deploy a application running it in our compute environment, whichever the compute that you are targeting on, right? So now we understood that any application that you are going to make it available to the users, right? It will be working as like a three-tier architecture, right? At least. So the three-tier architecture is all about the front end and the back end and the database, right? And you all know now the reason why do we need to use the three-tier kind of the application, right? Because it's not possible to achieve the beautification of your website, right, by taking one single programming language and just run it, right? So like whenever the end user is accessing the web application by going to their browsers, right? So the front end is the one which takes care of which takes care of giving the user experience, right? And let's say here I'm using the React application to give the user experience, and definitely, right, we need to have the scalability and the high availability for all the levels or all the tiers that we are using, correct? Just to repeat, whenever you are running the application, right, could be a front end, could be a back end, or maybe a database, as much as possible try to see if you can provide a scalability, high availability, security, right, and the load balancing capabilities if possible, right? So how are you going to achieve that, guys? In general, right, rather running it as one instance or one replica, better you run with multiple, right? So that the end user traffic will be hitting on any one of the replica, and that's how I'm achieving the load balancing as well as the scalability as well in nature, correct? So that traffic will be received by the front end, and the front end will be, actually routing the traffic to the back end. The back end is my RESTful API right now, correct? So the RESTful API also can be deployed with the multiple copies, so that we'll get the high availability and even the load distribution as well. And of course, it helps us in terms of the scaling as well, right? Because horizontally, I'm actually scaling the compute resources to handle the load, correct? So the front-end request is actually coming to the backend, and whichever the backend RESTful pod or the RESTful application that receives, so that takes care of the actual implementing the business logic, right? So this RESTful API will now be connecting to the backend database, right? So if you look at this architecture, guys, I'm not really worrying about how these are getting connected. You got me the gaps there, right? I'm just giving you some high level how I'm going to implement the stuff, right? Because the network path, in the sense, how are you going to achieve the load balancing, right? How one front end is connecting to the back end, that's all differs based on whether you are running these in EC2 or in Docker container or in a Kubernetes pod or in a on-premises. Getting me, guys? Is it true or not? Right? So that will get differ based on the compute environment that you are targeting, correct? So that's the reason I'm not putting that into the slide now, because if I put a load balancer there, probably you think that this is applicable only for the AWS EC2 instances. If I put a Kubernetes service, you may think that it is applicable only for the Kubernetes layer, right? So by now we are all familiar that what are the different ways to achieve or to access the application when it is running in the EC2 or in the container or in the pod. So I'm not just, you know, I'm not just, I'm not calling out the network a path how the traffic is coming into. But just think of like the front end should have the multiple copies, the back end should have the multiple copies to achieve the scalability in nature. But if you look at the database, right, so the database is something special, right? So we should not treat the database as how you are treating the front end or the back end, right? Because the front end and back end usually is not storing any data in it. It's just a code. It's just run an application and receive the request and just respond it back to you. No data is holding off in the front end and the back end. But in the database, that is where I'm actually storing the data of your business applications, right? So it could be a MySQL, could be any other. I'm just using MySQL in the presentation here, but it could be any database based on the requirement and based on the type of the data that you are going to store, right? And we just need to look at the compatibilities. And of course, it's the developer's responsibility to decide what kind of the database that they wanted to use based on the business nature, based on the type of the data that the developer wanted to store, right? We are not the one to decide. And again, how the data is getting stored, how it is connecting, all this stuff is something related to the developers, how they are putting it into their coding level. We just need to worry about take the code, run it as application, and that's it. And ensure the connectivity part. Anyway, so when the data comes to the MySQL, right, or any database, so pretty much this cannot be scalable. Why? The data is storing in one place. If you put into multiple replicas, let's say I'm creating one more copy of my application, the database application, right? It won't work just like that, right? Because it is actually holding off some data, right? Do you think the request may go to the first MySQL or the request may come to the second MySQL copy? Do you think it will be getting the same data? It's not possible, right? Just like that, because it is actually holding off some data. Hence the reason when it comes to the database, right, there will be a concept called master database and the standby database, right? So the master database is the primary database where the backend will be connecting to store the data or to retrieve the data, right? Always the backend is connecting to the master database copy to put the data or to get the data, right? If the master database is failed, is down for any reason, then there is a downtime. To avoid that, we can have one more database, but that cannot work as like a replica, right? That cannot work as like in the sense if it is a backend or the front end, right? The request may come to any copy, any replica. It should work, right? But here the request should always come to the master only in order to put or to get the data, right? So why the standby here? So when you set up the master and the standby, right, whatever the data that is coming into the master, that data will now be get replicated to the standby servers automatically. Of course, we need to set it up in the sense. So when you set up the data mirroring technique between the master to the standby, then the data mirroring concept will ensure that all the data that is coming into the master will be get copied it into the standby server. Then for any reason, if the master database server is down completely, it is not accessible, no worry, the backend will start connecting to the standby server and start accessing the data. That is how we are going to achieve the high availability here, right? Still, this is not solving the scalability problem. We can't scale the compute resources just like that, right, for your database layer, right? So, but here I'm going to achieve the high availability at least. If one database is down, I have the another database that is serving the purpose. But how the data is coming over there? So the data mirroring technique will be copying all the data that is coming into the primary database to the standby database. That's how the backend can connect to the standby to fetch the data if in case the master database is down or not accessible, right? So whenever the primary or the master is back, again your backend will start connecting to the master and start using the data. That's how it works. So it's up to you. If you want the high availability at a database layer, you need to provide this replication concept. If you don't want the high availability, you can just work with a single master database. But right, there will be a downtime if that server is down or that compute environment is down, right? And these are all architectural related uh, discussions that I'm doing, guys. So you should have really a broader knowledge of all the basics that I have done so far to understand these concepts, right? I'm going a little deeper. So in the front end, I'm actually doing the compute scaling, right? And in the back end also, I'm using the compute scaling concepts, which is like kind of the auto scaling or whatever you call it as, because the terms will be changing based on the compute that you are using, correct? If it is EC2 servers, maybe a terminology is auto scaling. If it is a Kubernetes level, the terminology will be a HPA, right? So that will change, right? I'm just using the general terminology here. Now, there are certain databases which will be helping you to have a multiple replica databases, right? So standby is one concept. The another concept is master and the replica concept. When it comes to the replica concept, right, it is possible to have multiple replica copies of your database. You see here in this case, I have two replicas listed here. So the backend is still connecting to the master to upload the data or to store the data, right? But the master is now replicating the data into a multiple replica copies, and in the presentation you see 2 replicas. The goal here is whenever there is some data in the database, right, either you read the data or you put the data, correct? Put in the sense you are actually storing the data. Get in the sense maybe you are retrieving the data. Maybe technical terminology, right? Put or get, correct? Put operation definitely should go to the master only because we need to store the data into one single place only. But the get operation can be done from a multiple replica copies because the data that is got put into a master DB is actually replicated it into multiple different replica instances. So the backend application, the REST application can read the data from any of the replica instance. Why we are doing this? Just to improve the reading performance at least. Getting me? If the backend application is writing the data to the master DB, reading the data from the master DB only, then there are high chances that the master DB is overburdened and it is heavily utilized because same master DB is using for writing and reading purposes. So to avoid that, we can configure such a way that, right, master is only for writing operation, the replicas are for reading operation. That will be good at least. How the application can read it from replicas, because whatever the data that got stored in the master, that is anyway got replicated it into the standby, or sorry, replicas, so we can read it from there as well. That way at least I'm avoiding that the reading and writing going into the same server. So put operation will go to master, get operation will go to replicas. That's how I'm just differentiating the read and write operations to different servers to improve the performance. So do you know, guys, how do you run a front end or the backend application? I hope so. Yes, right? It's very simple, right? I don't need to show you again, right, how the front end works, how the back end works, right? It's just application. You take the code from developer, right, and you just put it into your application server wherever it has to be, and that will run it, correct? Which is as much as like how you have deployed a Apache application and application, and the website is came up, right? Same thing. The only difference is if it is front end, I need to use the React, the commands will vary. If it is backend, I'm using the Java Spring Boot application, the commands will vary, right? So in the front end, I'm using the application. Sorry, I'm using the web server that can run the React application. In the backend, I'm using the Tomcat, which can run the application. That's some significant changes will be there from the technical perspective, but the overall process is same, right? Agree with me? Take the code, you just try to build it, just deploy it, run it. But when it comes to the database, right, this is not going to be the same thing, right? There's nothing like where you do build and deploy, because there's no code such that, correct? So it's altogether a different concept altogether. In the sense, if you ask me, out of this whole bunch of 3 layers, right, setting up the database is really a painful activity. That's what I'm trying to come up here, correct? So setting up the database is really a tough task out of all these different 3 layers, right? Because we need to set up the database, master, standby, replication, right? And again, for any reason, if your database layer is got terminated, corrupted, there is a huge data impact. I meant to say there is a huge business impact, correct? Just understand like this, guys. Let's say one of the front-end instance is down. Do you see any at least a data loss from the business perspective? If one of the backend application is down, do you see any impact? No. right? But if your database is down, definitely there will be an impact because that is holding off your data and it does not have much high availability as well. And of course, there is a high availability, but still it has significant impact. And setting up that database is also a very painful activity, right? So as I'm keep on saying that from the computing perspective, it's up to your choice. You wanted to run this whole setup in the on-premises or in the EC2 or in the Docker containers or maybe a Kubernetes pod. It's up to you where you want it to run, right? Based on the compute target that changes, the process will also change and the connectivity method also changes, correct? But though we are understanding all these different layers, right? Definitely the Kubernetes pod is the end goal for me, correct? No one is happy to run these applications in the EC2 level directly nowadays, right? And we know the reason as well and the advantages that we get it in the Kubernetes pod level, right? So, so definitely the goal here is to run all of these things in the Kubernetes pod itself, correct? Running the front end in the Kubernetes pod is so easy. Just matter of you create an image and run the image. Running the backend in the Kubernetes again is so easy. Just take the code, you create an image and you run it and you maintain whatever the replica count that you need it. So simple. But when it comes to the database, right, running this database in the Kubernetes is really a challenging, right? Hence the reason, of course, if you want, you can run the database as well in the Kubernetes itself, right? But since there is a complexity involved in running these databases in the Kubernetes, right? Sometimes the organizations may follow the databases as a managed solution. This means that the cloud providers are actually giving you the databases as a managed solution. In a sense, the cloud providers will ensure they only installing the database software, they only configure the database software, they will set it up the master standby, they do the replication for you, everything. Whatever I talked about here so far, all this whole setup will be done by the cloud provider. They will just give you the MySQL server endpoint or the URL to connect with. You just use that URL, give it to a backend application. Hey, this is the URL that you need to use to connect to the database. That's it. So simple, right? So hence the reason now, in order to implement this whole this three-tier architecture, right? Uh, Tell me one thing. Where do I need to get start with? Do I need to start with the front end or do I need to start with a database? Let's say nothing is as of today. I just need to start implementing this whole no three-tier architecture, right? So you need to get start with the database, right? So if you see this hierarchy, right, the front end is connecting to the back end is connecting to the database. If you go and start deploying the front end, right, it will try to connect to the back end. By the time, do you have the backend application? No, you'll get error, right? When you're deploying the backend, if there is no database already available, then the backend application will be failing, or it will at least give you some errors that, hey, I'm trying to connect it to the database, it's not available. Getting me? Right? So in general, right, you first prepare your database where you wanted to store the data. Then you deploy the backend that start connecting to the database. Once that is done, then you deploy the front end. That's the actual process how you are going to set it up from scratch. Now, when it comes to the database, right, what kind of the database it is? Why do I need to use the database? Right? What are the different ways are there to use the database? So in order to start explaining this, right, first of all, why do I need to use the database? For example, I'll just go with one of the website. Maybe, do you have edwiki.com? Well, this website is up. Good. So let's say this is the website, right? I'm just taking as an reference. Okay. In this website, I have a lot of content, right? All this data, in the sense content, all this data should definitely come from my server only, correct? Wherever my website is running as application, right, it has to come the data from there only, right? If you closely look at, right, here I'm having the data like images, right? All the images that you see in this portal, right, that is one type of the data. The data which is in the file format, correct? The images means what? Image is just a file, right? In general, JPG or PNG or whatever it is, right? The data that is in the file format, that data can be stored it in the S3 buckets. So in this database layer, right, we can even use the S3 as well, but only the data which is in the file format can go to the S3 bucket, right? The developers know how to store the data it into which databases or which storage related backend. We don't need to worry about that, how that is being happen, right? I'm just only focusing on what kind of the data that we may be expecting it to store. If the data is in image format or anything in a file format, that will go to S3. Good. You already know, right, the S3 advantages, which we don't need to worry too much about the scaling or any other things. Good. But if you look at this website, right, I have the sign in option here, right? And here I have the create option. Like, this is the place where the users are actually registering their accounts, correct? The sign up option. Let's say here the user is entering their first name, last name, email, a password, and you click on sign up. So this whole UI, whatever you see in the screen, right? This is actually coming as a user experience by using maybe a React.js or AngularJS. You think like that. Now, once you fill up this form, once you click on sign up, then the four parameters, right? The first name, last name, email, password. These four parameters, these four values will be given to the backend. Hey, these are the four values that the user has supplied in this form, and you store these four values in your database so that the next time when the user is trying to sign in by giving the email and password, you please compare the provided credentials against the data that you have saved when he was registered an account. If the details are matching, you allow the sign in, or else no. That's the overall the functional flow, how it works, correct? In this process, what kind of the data that I'm storing, guys? The data which is in the field format, correct? This is not a file format of the data that I'm storing in, correct? I'm just storing the first name, last name, email, and the password. This is the information that I'm going to store. So do you think this data can go to S3 bucket? Definitely not, right? This is not in the file format. So this type of the data definitely should go it into the database, right? Because this data should be stored in the a structural format. When I say structural format, at least this data should be stored in a tabular format where you do see some kind of rows and column kind of, right? In general, you take a Excel sheet. Maybe the Excel sheet is a good idea to store this type of the data, right? We have some first name, last name, email, password as four columns. Whenever the user is getting registered, you keep updating the rows. It's easy to manage, right? I need that kind of the storage space to store this type of the data that is feasible using the databases. So that's one requirement. Like that, there are different type of the data that we may be storing it in. So from the database perspective, right, there is a MySQL, there is a MongoDB, there is a Cassandra, there is a Redis, there are a few other guys. Each database has specialized expertise for storing a certain type of the data. So based on our requirement, we need to choose which one will be the best. But for now, we'll not worry too much about what kind of the data that the other databases are storing. That's not the scope, right? I'm just giving some context, right? That there are other databases also available to store the different type of the data, right? But for now, just to understand the concept, right, we are going to use the MySQL to understand how it is actually storing the data. So at a high level, right, whenever the client is trying to access the website in order to do the user registration process, right, that request will come to the app server, which is your RESTful API, right? So the app server will be connecting to the database, right? So here we can use a database like MySQL, PostgreSQL, Oracle, or SQL Server. These are the four databases got popular in terms of the RDBMS. RDBMS in the sense relational database management systems. In the sense, right? In the sense, the architectural, in terms of the architectural, right? All these databases, MySQL, Postgre, Oracle, SQL Server, all these four are following the same architecture in terms of the way how it is handling the data to store it or to fetch it, right? In general, maybe just for understanding, right, the any database that is following the RDBMS model will be storing your data in the tabular format in a you know just to make it more easier. Tabular format in the sense, it is going to create a table structure in your hard disk, right? So whichever the hard disk that is attached to this MySQL or to any of the databases, the data will be stored in the hard disk in a tabular format. It creates a table, it creates a row and columns. Then whatever the data that is coming from the app server, that will be get stored it into the column formats or in the row format. That's how the structure will be maintained, right? So the put operation is basically like uploading the data to the database, and the get operation is all about fetching the data from the storage and giving it back to the user whoever is actually looking for the data. That's how it works. Good. I'm just driving through all these different uh, slides just to get more familiarity about the concepts, guys. Okay. Now, as I said, installing and setting up this whole database by yourself is very trivial. At least in the Kubernetes, it's very difficult to manage this whole database by yourself, because what is the case if the pod gets restarted? What is the case if the pod gets terminated? We just need to follow all the best practices to ensure that the data is safe, right? Hence the reason, right, the people are following the Amazon RDS. Amazon RDS is the managed database solution that is provided by the AWS. So the RDS, the database is available to you as a platform as a service model, right? That means they will set up the entire database for you. You just need to use it and configure it in your app server that start working for you. That's how it works. Okay. Now let's see how do we create a RDS instance, right? So as part of this 3-tier architectural setup, right, the first thing I'm trying to see how can I set up the RDS, which is the database in this case, right? So If I go to my AWS account and let me search for the RDS. RDS is the relational database service, which is the AWS service to give you the database, right? So here you can see the databases tab and click on create a database. You can go with the standard or the easy create, right? Nothing much difference, guys. Standard will ask you all the different options. Easy will mask certain no, unnecessary options. It will ask you only certain important parameters only, nothing much. Okay, so let me go to the standard here, and here you can choose which database software that you are trying to use. As of today, AWS is supporting all these different flavors: PostgreSQL, MySQL, MariaDB, Oracle, right, and IBM DB2. So you can choose whichever you wanted to. You, in the sense, in general, the developers will choose the database. Probably you need to create a database since you are the infrastructure guy, right? So let's say I'm using the MySQL here. Then you specify the version, which MySQL software version that you wanted to. Let's say I'm just using the version called 5 point. Now specify that you are trying to use this database for production purpose or the dev purpose, or you wanted to go with only the free tier. If you select free tier, whichever options are applicable for the free tier limitation, only that will be selected and the rest will be grayed out, right? Just to call out all the different options, right? Let me choose the production here so that all the different options are available here. So to get a high availability of your database, you need to go with the multi-AZ concept. If you do a multi-AZ, the AWS will be setting up the primary database, which is the master database, in one availability zone, the standard database in the different availability zone. If the master is down, there's a standard DB is available, right? If one zone is failed, still we have the database running in the different AZ. That's how the instance level failures and the zone level failures are addressed if you choose the multi-AZ DB instance option here. Of course, the billing will be high because they are maintaining two different copies. If you don't want that, you can just go with a single DB instance so that there will be no standby servers, only one primary copy will be there for you. And if that gets down, there is a downtime, right? Either you go with multi-AZ or the single DB, that is just a matter of how AWS is managing it in the back end. For you, it doesn't matter, right, what it is. You will get just a endpoint, use the endpoint, give to your application, whoever is connecting, that is, that will get connected to that, right? If you choose multi-AZ, right? If you choose multi-AZ, right? If the primary is down, how it is using the standby, the data that is coming into the primary, how that is replicating to the standby, right? How the application can connect to the standby or to the primary, to whom it has to connect. Nothing to be worried from your side. Everything is handled behind the screen by the AWS itself for you. You are not handling any of these, which I have talked about just now. If you set up the database by your own, by downloading the database software, install it, all these things, then you need to do all of these things right by yourself. Hence the reason it's better to use the managed services, and which will be eliminating all this infrastructural related maintenance by yourself. Now let me choose a single DB instance for now. This is the database name. You can use any database name that you like it. and the username to access this database, and the password. Right, the database has to be set up on which instance, and you see the instances here. Pretty much AWS is going to create a EC2 instances behind the screen to set up the database, nothing else. They create a EC2, they will install the database software, they do the configuration, they will give you the database endpoint for connectivity. That's how it works. So definitely you need to tell what kind of the instance type that it has to use to set up the EC2 instances behind the screen, right? You can choose based on the instance compute requirement that you have. And the storage, definitely, right? When I say database, it is going to store some data, right? And it just need a EBS volume for sure. So select the EBS volumes that it has to use to store the data. We already familiar about the types and all. Specify the volume size based on how much data that you are expecting to store in the database. You specify the volume capacity here. For now, let me go with the 20 GB, right? And just come down. Let it be all these are defaults. So the public and private in the sense, your database will be accessible by the public, right? Public access no in the sense your database will be accessible only within the VPC, not from outside. What do you think, guys? In general, your database will be a public or a private, right? It should be a private always because your database is accessible only by a application servers, right? No one will access the database directly by the end users or from public. So it should be no here, right? If it is no, we can't access this database from my local systems, right? In general, until unless there is a VPN setup like in Office. For that reason, I'm choosing yes for now so that I can access this database from my local system, right? That's it, and let it be all other defaults. So this is how the estimated billing for me. Let me go and click on create a database. If you choose free tier, you don't need to pay anything, but here I went through the different options. So that's it. Just click on close. Now you see that the AWS has started off preparing the database for you. For understanding purpose, I'm saying that the AWS is creating EC2 instances for you and installing the database software on it. But you don't see that instances in your EC2 dashboard, guys. That is completely a transparent. AWS will handle it behind the screen. You don't get to see those EC2 instances. For you, it's just matter of going to this database instance. Once this database is completely ready, then you will get the endpoint here. You just need to use this endpoint with your username and password. Just access this. That's it. You don't need to worry about how the servers are deployed, how the DB is configured, and all these things are done by the AWS for you. Currently, it is in the creation status. I think it will take at least 5 to 10 minutes in order to set up this whole database. Once you get this endpoint available, you can just connecting to the database and start using it to store the data. Whatever the data that you are storing here, that will go into the specific EBS volume that have been attached, like 20 GB volume. The data will be in a tabular format. That's how the database software will help us to store the data. So far so good, right? And let me refresh. Yeah. Once the database is completely ready, then I'll show you how to connect it to the database and how to deal with this. Now coming back. right? So with being said that my database is completely ready now, my AWS manager service is flexible to prepare this. The next thing is the backend, right? So how to use the backend and how to build and deploy this, correct? Let me see this stuff. While AWS is preparing the database for you, let me talk about the backend, right? So here for the backend, I'm going to use the Spring Boot application. Just think of like a Java application for now. Okay. Whenever the developer is writing the Java code, right? And when you get a Java code from the developer, as I said, you can't use the Java code as it is to run this. Always the Java code that you get it from the developer, which I'm calling it as a source code at this time, that Java source code has to be given to the build tools like a Maven, right? The Maven is the build tool, which is very specialized tool to build only the Java source, right? All the Java source code that you get it from developer, that code will be now compiled and build and creating a artifact file for you. Artifact is just a general terminology which says that the output file that is got generated based on this process, right? Whatever the Java source code files that you given to the Maven will just create a file with a .var extension or .jar extension. It could be any of either of these. Whenever you are using the Maven build tool in order to build your Java source code to create an artifact, Maven is expecting the code to be in a specific hierarchy, in a specific directory hierarchy. If you look into this slide, the actual Java source code is there in the file called homecontroller.java, login.java, register.java. These are the actual files where the developer has written a code. But this Java code should be in a proper directory hierarchy, that is mandatory. If you see this flow, I have a top level one folder. Inside that, I have the src folder. Inside that, main folder. Inside that, Java folder. Inside that, right, there are a few other folder structures, right? That is a mandatory folder structure that must be followed to maintain the code base case. Then only the Maven can take this code, can go for the build process and create a artifact file for you. We just need to understand what is this mean by why the code is in this directory hierarchy, but it's the developer's responsibility to maintain the code in the required hierarchy, guys. We don't need to worry about any of this. You just take the code, give it to Maven. Maven will just do it for you. When I say a build process, right, the Maven is primarily doing two things. It is going to do the compilation on the source code, in the sense it check for any kind of the dependencies or the code layouts, or maybe some kind of the syntax related issues, that kind of things that it is doing in the compilation. And it generates the code in the binary formats. Hope you are following me, right? Because when you get a code from the developers, right, when you get a code from the developers, that is the plain text formatted code, in the sense we can easily go and read the code. You see the files .java, like how you guys will write the code as .tf, .py, like that. the developers are returning the code in .java formats, right? Which is plain text format. So that code will be compiled, in the sense it will be generated as a binary file where you can't read the binary file. Only the systems can understand it, right? That's the compilation. Packaging, in the sense, again, it is going to combine this whole process, and it generates a single artifact file for you, just a single file. No matter how many number of files that the developer has given you, after the Maven build process, you will get only one single file. That single file, that single artifact file, will be carrying all the different files that are came through from the source code. Now, whenever you get a Java source code from the developer and you give it to Maven, how Maven will understand it? In the sense, how Maven know that how to take this code, how to build it? Should I create a .jar file or a war file? How it know all this information? So in the given Java source code, there is a file called pom.xml. Pom.xml is the project definition file. This file has all the details that the Maven can use for the build process. That means whenever the source code is given to the Maven, the first thing the Maven do is it will read the POM file, understand the project, see the way how it has to take this code it into the compilation and packaging, then the artifact files will be created. Is mean that whenever you are working on the Maven project, right, the pom.xml file must be resided in your home folder where your source code is there. Then only Maven will pick it up and can do the stuff for you. If you don't have the POM file, Maven don't know how to take this code for the build process. Who is responsible here, guys, to prepare a POM file? It's not you again. I'm giving this context so that you will be familiar about how the Java source code will be there, how you will be working on. But writing the POM file, what should be there in the POM file, right? Everything will be done by the developer only. Now that is a POM file, and under the SRC the actual source code will be there, and there is a folder called resources. Under the resources folder there is a file called application.properties. This file has some details about the external dependencies in general. Can you think of like what are the external dependencies, guys? In the three-tier architecture, right, the front end the backend application is connecting to the database, right? How would your backend application know that what is the database URL, what is the database username, what is the database password, correct? How it know that to which database I need to connect? That kind of the information you can keep it under the application.properties file. So in the application.properties file, the developers will be mentioning, hey, this is the database URL, this is the database password, this is the database username. That kind of the information will be putting in the application.properties. Then when you give this whole bunch of source code to the Maven, Maven will build it, will create artifact. And as I said, the artifact file is holding of all this entire source code, right? Now, when you run this artifact, it can understand which database that it has to connect because you already kept that information in the application.properties file. Again, who will do that? Developer only, right? Probably you need to give, hey, this is the database URL, this is the database credentials. Then it's the developer's responsibility to use this information and integrate that in this configuration files and make the whole source code ready. Once the source code is ready, they will just give this source code to you guys in the Bitbucket in the specific branches. You take the code and configure it in the Maven build process and create a artifact out of it. In this whole process, right, you do not worry about the commands, how this will be get executed. You worry about only the process, what kind of the problem that it is solving, and how the different tools are getting integrated. That's more important, right? Implementation is very easy, just matter of running some set of standard commands. When Maven is creating a artifact of type var or a jar, basically the developers will choose the decision, right? This project should create a var file or a jar file. What is the need based on the requirement? The developer will be mentioning that in the form file. Hey, I want a var file, or I want a jar file. That is there in the form file. So the Maven will read the form file, will understand it, and accordingly it is going to create a artifact file format. But in general, right? So if your Java project is actually giving the web UI, then the artifact will be a .var. If your Java project is not giving the web UI, it is just built for a functionality purpose, then that is a jar file. In general, do you think the people will use the Java to build the web UI, guys? It is supported, right? I'm not saying that the Java is not supported. No, the Java is supported to build a web UI as well, in the sense user interface, like which color that I would need, how the button should be there, right? And how the animation should be there, kind of how the images should look like in my website. That is called as a user experience, right? We can achieve the user experience using Java also, but that will not be that much great. It's very basic level. So if you are using the Java to build the web UI, then the artifact will be a var. If you are not using the Java to build the UI, maybe you're writing the program only for some logic execution, some functional execution, then it will be a jar file. If it is just doing the functional execution, who will take care of giving the UI, guys? The front end there, right? The front end will take care of giving the user experience anyway. So most of the times, definitely, if you are working on the Java projects to do the build and all, it will be a jar file only, and it will be like your RESTful APIs only. We will not be using the Java for building the UI, guys. UI is always a front end, right? Which is the Angular or the React applications. Are you following me? Whenever the artifact is ready, let's say the var or jar based on the requirement now, right? Whenever the artifact is ready, that is the artifact that I need to execute it now, right? To run this Java artifact or the Maven artifact, we need a application software. Apache Tomcat is the a popular application server that can run the Java websites or Java applications. So we need to install and configure the Apache Tomcat, and Apache Tomcat listens on port number 8080 by default. Apache Tomcat will have its own home directory where you need to copy the artifact. In general, it will be a web apps folder, but it could be anywhere as well, right? But don't worry about that folders and all. In general, the Tomcat has its own requirement where the file is supposed to be. You copy the artifact and you keep it in the required location. The Tomcat will start picking up that artifact file and will be serving the content. So now whoever is trying to access this application will be sending the request to the port number 8080 of your Tomcat. Then the Tomcat will pick up that artifact from the web apps folder and will be giving the response back to you. Here I'm showing like www.redshopper.com is hitting the Tomcat, right? But but we have to visualize like this, right? The request may come to the front end. The front end will give it to the back end. I'm just saying that someone will call the request. The request may not be coming to the Tomcat directly, right? It may come via the front end and then the API gateway and may come to your application servers as well. But I'm just putting that someone is calling and the request is landed over there and the application server will be responding it back to the user. That's the whole process now. So in this whole process, right, the developers are there for you to write a code and give it to you. After that, taking the code, doing the Maven build, creating the artifact, deploying the artifact it into the Tomcat level, run it, and make sure that your application is running and accessible on the specific port number is all your responsibility. So here I can see that the RDS is currently showing it as available, right? Now I can see that the RDS endpoint is available here and I can see that the RDS is listening on port number 3306 by default. So just to confirm, as I see it in the chart window, yes. Once you get an artifact that is the file with the .var or jar extension, right? This is the file that you need to copy to the Tomcat server. Then the Tomcat will execute it, start it, and serve the content on this 8080 port number. Well, so now the database is available, right? Let me log into this database and we'll show you how the database works. So for that, let me keep, I mean to say, let me go for a mute for 30 seconds, guys. Right? Then I'll show you how to logging into the database. Okay. If you have any specific questions, just let me know on the chat window. All right, team. I got my glass of water. Now it's obvious, right? RDS is just a AWS service, and obviously you can deploy this using Terraform, right? I just use the UI to make it more simple. Yes, that's how it is. Now 3306 is the port number where the RDS is listening on. So let me go to the security groups just to see the port number is allowed. So I just look at this. Yeah, I can see that the port number 3306 is currently allowed. So I'm good. Now let me copy this endpoint. Like how you guys are logging into the EC2 instances using the SSH client like PuTTY. Similarly, to access the database, you need a database client software. Okay. So since I'm using MySQL here, you need to look for the MySQL client tools. You can see here the MySQL Workbench, PHP MyAdmin, and there are few other. All these are the MySQL client softwares which we can use for connecting to the MySQL server. So the most recommended one is MySQL Workbench. You go to the MySQL Workbench and download the software and install it in your local system, right? Then this software will help you to connect it to the database. So you can just go to the MySQL Workbench official portal and just download and install it in your system. In my case, I have the MySQL Workbench already installed, I believe. Yes, it's there. So I'm just opening the MySQL Workbench on my local system. It is still loading. Right now I can see that the MySQL Workbench is opened here, right? So all what you need to do is just click on this plus symbol. Now it is asking for the details of your RDS, which is your MySQL server. The connection name, let's say this is SRE 11 RDS. I'll say ED RDS 01. The connection name could be anything that you like it. The host name, this is where you need to give your MySQL endpoint. 3306 is the port number. The username is admin. Password admin 123, right? And let me test the connection. So the connection is successfully tested, right? And just click on OK. Now you see that the connection is saved here. Just double click on this so that now it is trying to connect to the MySQL server. Once the connectivity is done, it will open the MySQL database like this. This is the UI, guys. Right now, the time to work with this MySQL software, I mean to say MySQL database, to start storing your data. Are we good now? You don't need to be expertise on the database side, but having a minimal knowledge is enough. So at what level you need to be familiar with, I'm just covering that much only. We are not going in very deeper because we don't need to have the database administrator skills here, guys. Okay, we just need some information, that's it. Now the MySQL is ready. I have connected as well. Now I wanted to store some data, right? And what kind of the data that I'm planning to store, guys? Probably I'm planning to store the user's first name, last name, email ID, a password, correct? This information I'm planning to store it in the tabular format, right? So to store the data in the database, let's say this is the MySQL database, right? So first we need to create a database. Don't get confused. That's the reason I'm calling MySQL as a database engine. That means MySQL is just a software, right? In that MySQL software, we need to create a database, right? And you give the name for the database, whatever the name that you like it. Now inside this database, now we need to start creating the tables. You create a table and you give the row and column structure how you want it to, right? Which is called as a schema. from the database language perspective, right? Once you have got the table schema, in the sense the structure, guys, like how many rows that I'm looking for, how many columns that I'm looking for, right? And what could be the title of each and every column, what kind of the data that I'm going to store. Deciding these parameters is called as a schema, right? Once this table schema is ready, right, then you start putting the data in it. It's up to you, in the sense it's up to the developer. They wanted to store the whole bunch of data it into one database, into one table, or divide the data it into multiple databases, into multiple tables. It's up to developer's choice. When I say database, it's a single MySQL. Inside that, I'm having multiple databases, guys, possible. Here you see that the username and password is in one database in the one table. Email and the other information is in the another table in the another database possible. It's up to developer how they wanted to manage the stuff, right? And then you actually store your data it into the specific row format like this. The application know exactly how to insert the data or how to fetch the data in this particular table formats. The developers know exactly how to put the relation between the one database to another database, because if you see here, one user information is split into multiple tables, right? The username and password is in one table, email, phone number, address in another table. How do we understand that, right? This user information, the contact information is in the different table, right? That's where the developers will use the concept called foreign and primary key concept. So using this, they will try to understand the relation between the tables. That's where it is RDBMS, Relational Database Management System. Anyway, we don't need to worry about these things for now, right? Since we are not really working on no, developing the applications using MySQL, right? Just giving some context only. The reason I'm giving all this information, right, though you are not working on these pieces, right? When you go into a project, obviously, right, you are going as like you are a working guy or worked on this domain since last couple of certain time, right? So definitely this is the knowledge that you must be gaining in, right? Since you work since last many number of years on this domain, right? That's the reason. That's how you are projecting it as well, I believe, right? Anyway, so now let's start doing this. The step number one is need to create a database. Step number two, create a table, right? And create a table schema. Then we need to start putting the data into this, correct? To create a database, create a table, all these things will be done using the MySQL commands. So rather using the command terminology, we call it as a query, right? The MySQL queries are a kind of the commands which you need to use to work with the MySQL, guys. And here you can see some of the MySQL queries, right? So we don't need to be, learning all of these. I'll just talk about a few which we need to be familiar with, at least to get a start with our, I think let me get some details from my Bitbucket. Yeah. So here I have some information, right? You see, let's say here I'm planning to store the username and password of a user who is registering an account in my website. That's my goal. Okay. What I do is first I'll see is there any databases that are currently in my, let me Give me a second. Yeah. Show databases is the command to see is there any databases currently. My UI is very slow. Yeah. Show databases is the command to see the databases. Copy the command. This is the editor panel where you need to compose your commands, and click on this shark symbol that will be executing. You see, by default, it has these databases. Okay. Now you can create your own database. Create a database and the database name, right? So this is the command to create a database with the name called userdb. So let me execute this command. Now the database is created. You can see the output here. You can verify the databases again one more time. Now you see that user DB is the database that is just got created. Right now you use the database, right? Say, I mean to say, out of these databases, which database that you wanted to work with. This is the statement that you need to use to specify that I wanted to use the user DB. Now you see, is there any tables currently in the database, right? Show tables is the command to see the tables. Currently the tables are empty. There are no tables. Now you create a tables, right? Create table, the table name, and you specify how many number of columns that you need. I need a first name, last name, email, username, password, so on, so on. And what kind of the data that you wanted to store? Is it a characters, strings, integers, something like that? How many number of characters that you wanted to store? So this is what is the table schema. Schema in the sense the structure of the table. I'm not storing actual data here. So let me copy the command. Let me execute it. Now the table is created, right? So describe table, I mean to say describe and the table name, right? That is the command in order to see the table schema. You see, I got the table. The table has some fields like columns, and what kind of the data that the each column can store, that is called as a schema here. Now let's see, is there any data in the table, right? Select star from employee. That means from the employee table, please show me all the data. Star means all. That is what is it mean by this statement. Copy that. Let me execute this. Currently, you can see that your table is pretty much empty. It doesn't have any information. So far, I just have created a table with the required schema, how I'm planning to store my data. What is my next step, guys? Now, what I can say is I'll go and inform to my application, correct? Hey, application, you please connect it to the MySQL database, which has already some table ready. So whatever the data that you get it from the website, when the user is registering a account, that data you go and update it in the respective table where the table is already created. Getting me, guys? That's how it works. Whatever the MySQL commands that I have executed here, like creating a database, table schema, all these will be done by the developer only. I have executed here so that you'll get a better clarity how the things are happening, but this will be done by the developer only automatically. In the sense, they manage everything from their code level. which we don't need to do any of this. But having this knowledge is definitely helps you guys to understand how the things are happening. What next, guys? So quickly, can I go and start building and deploying the application? It's a simple, right? So now my DB is ready. Now the developer is giving the code. So this is the code. Let's say the developer has already written a code, right, in a Java. The code is committed to the Bitbucket repository here. Here I can see the src folder. I can see the pom.xml folder. Right, under the src, under the main, right, under the Java, you see this is where the Java source code is there. The developer is maintaining the whole directory hierarchy, how the code has to be. This is our actual Java source code, right? Anyway, I'm not worrying about this whole code, how it is written. The developer has given the code. I'll just take this code and run this, correct? So what I do is I'll go and create one simple EC2 server because I need to take the code and do the build process, right? That's the reason, right? So let's say I'm calling it as a build server where I'm trying to do the build process to create my application specific artifacts. A lot of process is involved. Yes, we need to go with this process. All the basics that we have covered in previous lectures will be helpful here to understand the concepts, guys. So let's say this is my build server. Okay. So now in this build server, I need a Git software because I need to clone the code that is given by the developer in the Bitbucket repository, right? So I'll go to the Bitbucket repository. I'll try to clone this. I will use HTTPS. This is the public repository. It will not ask for any password. Now I can see the java-login-app. So in the src folder, in the main folder, in the resources folder, you can see that application.properties file, correct? I said that this is the file where the developer has to keep the database connection, right? You see here there is a syntax, the JDBC MySQL :/ something like that, right? So this is where the developer has to keep the database endpoint, which database that application has to connect with. So in my case, the database is available in this endpoint. Let me copy that endpoint. Let me keep it here. Now I'm telling that this database, this RDS is accessible on 3306 port number / you see this user DB. That is the database that it has used for storing the data, which is already created, right? We did it. and the username and the password that it has to use for connecting to this database. So pretty much you have to understand like the external parties information that the application should aware of how to connect are kept in the application dot properties file. Okay. So don't worry about how to encrypt it or how to follow the best practices. Always I prefer work at a level one, then we'll focus on the best practices, right? So we'll see those best practices later to make it more improvise. Now this code I need to give to Maven, right? Now I need to install the Maven software, correct? So let me install the Maven. The Maven you can't install using a minstall command, guys. Okay, so you need to download the Maven as a binary format by going to the Maven official portal. Here you can see the download section to download the Maven, right? And to install the Maven, it is expecting some prerequisites, right? First, it is expecting the JDK packages to be installed, right? Then only you can work with the Maven, or else no. That is what it is saying. So first you install the JDK, then you install the Maven. JDK in the sense your Java software in a way, right? It has to work with the Java code, so the Java software has to be installed. So technically we call it as a Java development kit JDK package. So let me install the JDK first. Or let me see if I have the Java already. Java is not there. Yum search Java. I'm trying to see is there any Java packages that are available here. I can see the Java packages are available. I can see that here. This is the devel package in the sense the development environment. This is what you need to focus on. Okay. So let me take this package name. Yum install, specify the package name. The JDK is now getting installed. JDK is the Java Development Kit package, which is helping us to build the Java source code. Maven is doing, but Maven has to use the JDK help in order to build the Java source code, right? That is the reason the JDK is the mandatory to be available to do the build using the Maven. Once it is installed, you verify that by running Java -- version command, maybe Java - version. You see that now the open JDK is installed. Good. Now you download the Maven, right? So here you can see that the Maven software is available as part of the different archive formats. Maybe you can just copy the link from where the package can be downloaded. Maybe you can create a folder like OPT Maven. You can create a folder anywhere, guys, no matter. I'm just creating a folder in the OPT location, but doesn't matter, right? So you just download the software to any location that you like it. Now you unzip the package using unzip command.
Now you see that the application is extracted there. You go to the bin location, right? So I just have extracted my software, and in the bin location, mvn is there. This is the command that you need to use. Dot slash, from the present working directory, there is a mvn command, and I wanted to see the version. You see it's working. So now the Apache Maven is currently ready for you to use. No, we don't need to install, just download the zip file and extract it and start using. So the command is available in the bin location. This is the complete path. So if you don't want to run it by using dot slash, you can update this location, right? In which folder the command is available, that folder can be updated in the environment variable. In the Linux, right, path path is the environment variable to keep the folders where the no let me do this to make it more simple, right? So path is the environment variable which has the list of directories in which directories the commands can be located or commands can be searched for. All what you need to do is update your folder where your Maven software is available into the path variable, right? So all what you need to do is export path equal to $path colon specify this. In the sense, path is the variable that I'm setting up. $path in the sense whatever is there already, you include that. Additionally, I wanted to update the new one. Now, you need not to be in the same folder, guys. You see, I am in the different location. It should work. mvn hyphen hyphen version. The command is working without you specifying dot slash. That's how it works. My Maven is ready. Now, all what you need to do is go to your source code folder where your src folder and the pom.xml file is there, right? Just go to that location and run the command called mvn package. You need to run this mvn package command from the same folder where you have the src and the pom.xml file is there. By default, the mvn command is looking into the present working directory to look for the pom.xml file. It will read the file to understand how the project works. Then it will go for the build process. Now, it is actually reading the pom.xml file. It is understanding how the project will be. Then it is doing the compilation. It is doing the packaging. Finally, it will give you the artifact file based on the project definition that the developer has given. So when you see the build success, that means the build is done. When the build is done, right, there will be a target folder gets created automatically. The target folder was not there before. Once the build is successful, the folder is created. Inside this folder, you get to see your artifact file. In my case, I got the file in the var format, but it could be var or jar based on the developer's choice, as I said. Once you get this var file, now the time to give this var file to your Apache Tomcat, correct? Now I got my artifact. This is the file that I need to give to my Tomcat. For that, you need to download the Tomcat software, correct? So you can go to the Tomcat official web portal and start downloading the Tomcat software. The Tomcat software can be in 8 and 9, 10, 11 version, right? The developer will choose which version that we need to use because the code should be compatible for this, right? You can't use whatever the version that you like it will not work. At least the code that I have, which I have got it from my developer, is compatible for Tomcat 8 version. Hence the reason I'm trying to download the Tomcat 8 only. Just copy the link, go here. Maybe I'll create a folder for Tomcat. Duplicate and specify this. The Tomcat is downloaded. You just extract this application. Right now you go inside this folder. This is your Tomcat software. Go inside the bin folder. That is where you can see the Tomcat related executable binary files, the scripts in a way. By default, this Tomcat software, the binary files does not have the execute permission. So let me give the X permission. Right now, all what you need to do is run the script called startup.sh. So if you execute the script, now it will start. Sorry. If you execute the script, it will start bringing up the application, the Tomcat application on the default port number 8080. You can use the startup.sh or you can use the catalina.sh. Either way, it should work. If you are using a catalina.sh, you need to give that, hey, I wanted to start the application. Hit enter. I think we are almost done, right? In next 5 to 10 minutes, we should be able to bring up the application. It is telling that the Tomcat is started. How do you confirm that the application is started, guys? The Apache web server was so easy, right? Yum install HTTPD, systemctl start HTTPD, verify that it is listening on port number 8080. Here, it's a different way, right? The systemctl will not work because application is not installed. It is just a zip file that you have been extracted. You can run the netstat command just to ensure that the port number 8080 is currently listening by your Java application. Good. In the application home directory where you have extracted the software, there will be a folder called web apps. So web apps is the default location where you need to keep your artifact. That's it. If you keep your artifact in the web app location, that will pick it up and it will be starting the application for you. Let me copy my war file. Right, my war file is in Java login app in the target folder, right? So this is my war file that got created. I'm copying that file it into the present working directory, which is the web apps folder in this case. I just copied this. The moment when you copy the artifact, it automatically extracting this war file, it automatically creating a folder for you like this. Now in this folder, you have your entire application is hosted and it is running from that folder only. That folder is now called as an application, guys. If you want to access this application, this is the application name that I'm referring, right? So you need to access the servers on port number 8080, right? I need to ensure that port number 8080 is allowed in the security group. Right? So all what you need to do is the IP colon 8080, and then you need to specify the folder name, which is your application name in a way, right? Which is got extracted here, right? Usually your name of the artifact will be your folder name, will also be a application name. Let me specify that after slash. This is how I'm trying to access my application. Here you go. Now you have got the website accessed. It's a simple website. Don't expect the beautiful UI. Also, you can't get the beautiful UI using the Java, right? So I got some website here. I see some register option here. This is where I can register a account in my website. You see here, I'm getting the UI with a very minimal information, right? Why? Sorry, minimal user experience. Why? Java is not great to give you the best UI, right? I got very, minimal stuff here. If we use Angular, we'll get the best. Anyway, so I'm using my first name. I'm just trying to register a account in my website, guys, right? So let me use something like this. Okay. I'm just trying to register a account in my website. Let me click on submit. It says that the user account is added. Let me confirm that. What I do is I'll go to my database, select star from employee. Hey, I wanted to see the data that is there in the employee table. Let me execute this. Can you see the data, guys? You see that the user who has registered in my website from the browser, that registration details are actually stored in your database. You can see the first name, last name, email, username, password, the registration date, all this stuff. That's how it works. As of now, if you come back to this some more time, right? Of course, as of now, I'm not using this front end, right? My request is coming to my backend application directly. In the sense, uh, the Java application that I'm using, right? It itself is giving you the web UI. That's the reason, right? But it's not an ideal case in real time. So when the user is accessing your Java application and doing the registration, the Java app is connecting to the database and storing the data in the database case. Make sense? So to make it more beautiful, right, we need to keep the front end as well later. Anyway, for now, that is how it is working. If one more user is registering the account, let's say I'm just preparing some other stuff. submit. If one other user is registering account, that details should be coming to your database again. You see, another row is added here, right? Whenever the user is logging in, for example, the user is trying to logging into the website by passing the credentials, right? The username and password will be sent to the application. Application will fetch the details from database. It will compare. If the details are right, then it will allow you to logging into the website. Once you logging in, you'll get to see whatever is the the different features that your website is providing. It's just a basic website. Don't worry about this, right? I'm just showing that once you log in, you are able to access the further content. Just a demo application for now. That's it. So that's the DB and how the DB is integrated with the application server, which is a Java application that I have used here to build and deploy and run it in your Tomcat application server, guys. Sounds excited? So that's the story for today. If any questions, do let me know, or else we're good for today. And it need a lot of time for you guys to understand this whole process, guys. Right? So we need to go over at least 1 or 2 times to understand this whole structure, what's happening here. Right? Thank you.